Next, we visited Bern, Switzerland. Bicycle parking is allowed on specially designated portions of some downtown streets. They use yellow pavement markings for bike lanes and pedestrian crossings. Look at how prominent the pedestrian crossing is here. Yellow markings are also used for bus lanes, and they have combination bus-bike lanes. Special bike route signs are very informative. The older portion of downtown Bern is centuries old and was very charming with an old-world feel to it. In the newer portion of Bern, a very popular transit station is easily accessible for bicyclists. This is a very pleasant pedestrian environment to explore. As with Denmark, we were very impressed with bicyclist behavior. They were very mellow and law-abiding. Bicycling is embedded in the Swiss human-powered mobility plan, with walking, hiking, bicycling, and skating as elements. Pedestrian traffic is considered as one single system with three parts: motorized private, human-powered, and public transit. The human-powered mobility role in metropolitan traffic is 1. Full accessibility inside built-up areas, and 2. Linking private and public transportation. Look at how many people you've seen moved in this video clip with no car traffic at all. They have two-stage driver's licensing and strict legislation and enforcement on speeding and drunk driving. Car access to some portions of downtown is restricted by these key card actuated retractable bollards. The Aar River bisects Bern in a deep river valley. This creates a need for significant bridge structures such as the Kornhausbrücke Bridge in the background here. You can see the tram traveling over it. Look at how skillfully the oncoming cyclist is crossing the tram tracks. Also look at how many pedestrians there are in this clip and how well bicyclists interact with them. Bicyclists share the road with motorized traffic and the trams on the bridge, and then are routed onto cycle tracks, taking them behind the tram stops so they do not create conflicts with transit users. The trams run frequently, including 9-minute headways on Sundays. It was on a Bern tram that Albert Einstein had his breakthrough insight on the theory of relativity. We were impressed with how well Swiss bicyclists operated on this shared lane condition. There's tram traffic, car traffic, and bike traffic within the travel lanes, and many pedestrians using the sidewalks of the bridge. Consider how American cyclists might react to a similar situation, but for the Swiss, it works. Note the absence of any pavement markings beyond the white centerline marking. They do not use yellow for centerline markings in Switzerland. Here is a ground level view showing the transition between the on-street bicycling across the bridge to the off-street cycle track bicycling behind the transit stop. The curvature works out well, and cyclists seem to obey it. We were impressed with how this worked for people. The trams are actually quite narrow. This allows them to navigate the sharp curvature of the downtown streets that were laid out 500 to 1,000 years ago. Swiss helmet usage was 14% 10 years ago and is now 38%. But compulsory helmet laws are viewed as likely to reduce the number of bicyclists and thereby reducing the safety that results from large numbers of bicyclists. For the Swiss, the cardiovascular benefits of increased public bicycling are better than requiring helmets. Swiss bicycle accidents resulting in fatalities and severe injuries are 72% due to collisions, 23% due to left turns, 1/2 of which are the bicyclist's fault, and 13% at crossings. Children cannot ride a bike on their own until they are 8. The federal plan on transport is to develop human-powered mobility in built-up areas, eliminating the negative side effects of railway lines and highways on human-powered mobility, and coordinate national human-powered mobility networks. Most Swiss traffic problems occur in densely populated areas. They have their own national standards for signs, pavement markings, and traffic signals that are different from the Vienna Convention. Our Swiss host described examples of their land use policy that favored transit and bicycle use. The policy for new development was that it must occur along corridors with existing or planned transit service or bicycle routes. Note the through movement and left turn bike lanes with yield markings in advance of the pedestrian crosswalk here. Swiss pedestrian signals are actuated by push buttons that illuminate when pressed, confirming that the call has been sent. The Swiss routinely use flashing yellow beacons where right turns would conflict with pedestrians. Notice that there are 3 sets of pedestrian signals here, so that the pedestrian crossing is broken into individual phasings to get across this 4-lane street with 2-lane right turn bypass. Again, here's a close-up of the flashing yellow beacons and the 3-phase pedestrian signal heads. This intersection approach has a through right bike lane with a left turn bike lane located adjacent to the curb. Here is a forward view of the same intersection approach. Again, note the left turn bike lane adjacent to the curb, then the through right bike lane, and the through right bike lane advanced stop bar, allowing cyclists to queue in front of the motorists who have their own white-colored stop bar. We were routinely impressed by the ability of Swiss bicyclists to obey traffic signals. Note that they are queuing in the through bike lane while the left turn bike signal gave a green. The left turning cyclist has proceeded. The through movement cyclists are still waiting for their own green, and at that point in time, they continue on. They do not ignore traffic signals as we are so commonly used to seeing here in the United States. This close-up shows the left turn bicycle signal and the through right signal that is used by motorists. Note the flashing yellow beacon reminding motorists to yield to pedestrians in the crosswalk. Again, here is a view of the left turn bike lane. Note the angled stop bar and the geometry of the left turning movement that will result from this layout. Both of these cyclists are waiting patiently for the left turn bicycle signal, whereas a U.S. bicyclist probably would have just continued on through the intersection during a gap. These bicyclists wait, knowing that the signal has detected them and will give them a full left turn green bike phase. From the median, this is what the bicyclist's left turn movement looks like. Here is the corresponding pedestrian crosswalk at the same intersection. Notice the median refuge provided, and the crossing is made with 2 sets of pedestrian traffic signals. Also note there's a pedestrian push button on the median for a slower pedestrian who needs to put in a second call to get additional time to get across the intersection. Also note there's no bicyclists on the street charging through the pedestrian crosswalk, creating conflicts with the pedestrians, as the pedestrian signals operate on their own phasing. Another example of a median-protected pedestrian crossing made with 2 sets of pedestrian signals operating on their own timing to provide a phased, sequential crossing of the street. This worked out well, and I'm about to press the button again adjacent to the camera to put in another call. Note that the near side gives the green prior to the far side. Here is a median view of the previous intersection. Note the pedestrian warning beacons both at the near side traffic signal as well as at the pedestrian signal at the crosswalk. Also note the relationship of the signal to the bicycle left turn signal on the same signal pole. We are now looking at the crosswalk where you just saw the cars turning to the right in the previous clip. Bear with me, this clip lasts a little bit and we'll test your patience, but I wanted to show you how well this intersection works. There are 3 sets of pedestrian signals here. You see the flashing yellow beacon at a median refuge between the opposing directions of travel, and there's a 3rd set of pedestrian signals at the far side of the intersection leg where there's a right turn bypass. Each of these pedestrian signals is set on their own timing to provide the maximum amount of crossing time for a pedestrian. The signal that is currently red is for the near side crossing of the intersection. Then the portion of the road where you just saw the bicyclist run the red light was for the opposing movement of traffic. And there's a 3rd set of signals where the red car just went through. It's a right turn bypass. Notice how these signals function Again, maximizing the amount of green time given to pedestrians so they can cross each of the 3 individual crossings as often as possible without delay. This setup was quite interesting. Also notice that there are pedestrian push buttons on each of the pedestrian islands, allowing pedestrians to put in additional calls if they need additional time. This system worked quite well and was quite sophisticated in that it maximized the amount of pedestrian and traffic movement at any given time. The intersection adjacent to the rose garden was very interesting for us. Watch closely what this bicyclist does when he gets to the red light. Also notice that there is a bicycle box providing an advanced bike stop bar, allowing a queuing area for cyclists. When the traffic signal turns green, the cyclist will have the ability to move first before the motorized traffic, including the right turning traffic. Also note that in a moment, the signal will show a simultaneous red and yellow indication, indicating that it is about to turn green. You will also see the traffic signal have a flashing yellow beacon indicating that right-turning motorists must yield to pedestrians. There's also a red light camera in the foreground adjacent to the black SUV here that catches red light runners. Let's look at some of the other legs of the intersection. Again, the Swiss use the yellow for bike lane markings and pedestrian crossings. They're not bashful about using pavement markings. Here is the opposite leg of the intersection. Note the left-turning cyclist remains stationary while the through traffic is released. We'll be taking a closer look at the traffic signals here in a moment. Note that there is a transit signal, a through signal for motorists, a right turn signal for motorists, and a through and right turn signal for bicyclists with a convex Trixie mirror, all on one near side signal pole. This intersection is well suited to the needs of this family of bicyclists. On the approach to one leg of this intersection, bicycle markings indicate that through and right turn bike movements should be made from the curbside bike lane, and left turn bike movements should be made from the left turn lane. Note that the through right lane adjacent to the bike lane has a through movement yellow arrow for bus traffic. Overall, these lane markings provide guidance for both motorists and bicyclists, allowing people to queue up in the lane corresponding to the movement they want to make at the intersection. One leg of this intersection is served by bicyclist delayed left turn markings. These markings allow a bicyclist to make a left turn via a two-stage movement. First, by making a through movement through the intersection, then stopping on the delayed left turn marking, getting a second traffic signal detect from the in-pavement loop, then proceeding on the subsequent green signal so they can make a left turn without having to find a gap in oncoming traffic. Note the layout of the marking in front of the crosswalk. This leg of the intersection is served by a bicycle box in front of the motorist stop bar. Therefore, the bicycle traffic signal is on the far side of the intersection, since bicyclists are ahead of the near side traffic signal used by motorists. Let's take a closer look at how this intersection operates. Here we see motorists queued up, get the red-yellow indication prior to their green. Currently, they can make a left turn, through movement, and right turns with the flashing yellow beacons indicating they must yield to pedestrians in the adjoining crosswalk. Our hosts indicated that near-side traffic signals are effective at reducing motorist encroachment on the pedestrian crosswalk, as they will be unable to see their traffic signal if they overshoot the stop bar. Here is a close-up view of the signal phasing for all 4 of these signals. Note that the transit signal is in stop position the entire time. Through movement, motorist, and through movement bike movements are made in advance of the lagging right turn motorist signal, allowing cyclists to proceed without being a conflict for right turning motorists. The convex Trixie mirrors are located on the traffic signal poles adjacent to the signal heads and are very effective in allowing motorists to see bicyclists who may be overtaking them on the right in a bike lane in order to reach the advanced stop bar. Our hosts indicated these mirrors are very effective, reducing right turn hook type crashes with bicyclists. You can see me in my yellow vest taking video from the motorist vantage point in several of these clips. These mirrors are internally heated so they do not frost up in the wintertime. These mirrors are specifically positioned on the signal poles so a motorist will be able to see a cyclist well, both in the through lane and left turn lane bike boxes. Here is an example of a bike lane on an arterial street at an intersection with another arterial street. The bike lane is defined on the sign above the traffic signal and with the yellow pavement markings the Swiss use for bike lanes. Note that this lane is provided between two through movement lanes of travel. About half a mile further, the right lane will be used to access the freeway interchange. Many turning merging movements will be taking place at this interchange. Therefore, this bike lane is located between these two lanes to reduce conflicts at the interchange. Note how the bike lane is defined through the intersection with the yellow pavement markings. Look how well this family is able to negotiate this layout. In a moment, we'll see approaching traffic from a intersecting leg of the intersection. Note how these motorists successfully merge and yield to the bicyclists in the bike lane. Consider how this layout would be viewed by American traffic engineers and American bicyclists. But in Switzerland, their style of operations means this sort of facility works quite well. Again, the same approach to the same intersection. Look how bicyclists are able to queue up between the two lanes of through movement traffic. Look how well the bike lane is defined through the intersection. Look at the relationship of the traffic signal to the pedestrian crosswalk that results in reduced encroachments by motorists. This layout works out well. In Switzerland, we found that motorists were quite responsible, controlled, careful, thoughtful, and attentive. It was quite a bit different from similar operations at corresponding intersections that we'd see in the United States. We did not see any obvious law enforcement. We did observe an underlying social compact and ingrained traffic safety education that resulted in these sorts of operations between modes. Here, a bicyclist approaching the intersection from an intersecting leg is also able to use the through movement bike lane located between the two through movement lanes of travel. The speed limit here was 50 kilometers per hour, the equivalent of 30 miles an hour, and we saw motorists operated in compliance with that. Note the overhead signs defining the bike route condition on the street, providing guidance that it continues through the interchange. Here is an upstream view of the leg of the intersection we have been looking at. Notice how bicyclists are stopped in their own bike lane with an advanced stop bar defined in yellow for them. This bike lane is also served by an in-pavement loop detector, and this layout worked out quite well. Here is a pan view of the intersection. Note the layout of the bike lane with advanced stop line, the pedestrian crosswalk with median refuge, the bike lane channelizing markings within the intersection, and the overall quantity of both through movement and turning movement channelizing markings within the intersection box. At another leg of the intersection, we see a total of 4 sets of pedestrian signal heads to provide a pedestrian crossing of the 2 sets of through movement lanes and the 2 sets of right turn bypasses. Each of these signals is located with a pedestrian refuge with a pedestrian push button, so additional time can be called if needed. Look at the sequential operations of the pedestrian signal heads here. It is reasonably foreseeable that this pregnant woman and her family are going to move more slowly than a design speed pedestrian. Consider the value of the pedestrian refuge and the supplemental pedestrian push button in the island. Note the checkerboard layout of this neighborhood traffic circle pavement markings. The inset lane edge stripe provides a pusher island effect. The Swiss are keen on schoolchildren's safety. Each side of this triangular school zone pavement marking is easily 8 feet long. Note how prominently this marking shows up on the street. Ausgenommen means accepted. We frequently saw bicycle accepted signage allowing two-way use of otherwise one-way streets. This worked out quite well, actually. Regulatory signs exempted bicyclists from one-way and turning restriction conditions. Jug handle left turns are made from a storage area behind the right curb line with an actuated bicycle left turn signal and a Trixie mirror. These worked out quite efficiently. In construction work zones, temporary orange pavement markings are used for bike lanes, pedestrian crosswalks, lane striping, median striping, and yield markings at intersections. These markings are quite conspicuous and serve to convey the temporary layout of the construction work zone condition. Next, we saw valet underground bike parking.
To be able to park your bicycle here, you have to pay a yearly fee. It's 150 francs, $150 approximately. And if you want to park it just for one day, it's 1 franc a day.
But that 1 franc a day won't pay for the true cost of this.
No.
So where do the subsidies come from?
From the city of Bern. And it's like this is a project for long-term unemployed. They work here, and they also rent out these bikes. There's another place in town which rents out the bikes. People who are long-term unemployed. It's a program to reintegrate them in the working process. And they can stay here for half a year or longer and to learn to do repair works. Some people have been unemployed for a long time and they're not used to working with customers, have other maybe problems, and therefore they're trained to work, to get back into the workforce again. And the city of Bern built this together with other partners. We have to pay a little bit to the Federal Railways for the place, but they also then pay for bicycle parking around the station, so it's a rather complex model. Seemed to work. And it's not quite full yet here, this place, but it's only been open 2 years.